everybody, hi, Mike here. Today we're going to talk about part 2 of our titration lesson. We're going to do a switcheroo. Think about this. In our burette, we are going to put acid and we're going to add it to a base. I had a friend who used to titrate soap suds at Procter & Gamble and had to do this basically same thing. No pun intended with basically. Okay, so here we go. We're going to take, in this thought experiment, we're going to take 0.1 molar NaOH and start adding HCl to it. Here's our initial pH. Why is that? Negative log of 0.1 would be 1. That's the POH. This is our initial pH. Let's think about the equivalence point. What are you going to have there? You're going to have NaCl. That is a neutral salt. So when we add, we'll make them both the same concentration. Our equivalence point's going to be right there. So it's going to be kind of like the flip of the strong acid, strong base titration where it was the other way around. Then whoop, equivalence point is going to be pH of 7.00. That's going to be NaCl, neutral salt. What kind of indicator can we use? Well, let's think about what would happen with phenolphthalein. It would start pink. It would turn color at pH 8.3, which would be a fraction of a drop away from what volume would be pH 7, and it would turn colorless. So it's the exact reverse of when we did it the other way around, where the NaOH was in the burette and the acid was in the flask. Now let's replace this with a weak acid. Now we're going to say, what if we had a weak base? And you know what? I'm going to pick ammonia. You know why? I want to cheat. Because due to some dumb coincidence of nature, the Kb of ammonia is the same number as the Ka of acetic acid. I'm pretty sure that's just a coincidence. Ah, it blew away. And I'm back. I weighed it down with a brick. By the way, I've got that right outside Sinclair the other day, sitting right near the sidewalk. I just boop, took it. Hey, but I'm using it now for your educational purposes. So here we go, guys. Weak base, not going to have a pH of 13. We're looking at like 10 point something because it's partially ionized. Now, actually, let's talk about the equivalence point. Here, put it lower than pH 7. Why is that? Because you're going to have ammonium chloride. I'm going to cheat because same K in the last example, the pH of the titration of the weak acid, the pH was 8.72. The POH would be 8.72. So that's a pH of 14 minus 8.72, which is 5.28. Took me about 30 seconds. Don't got my calculator. So we're going to go along as, and then that's where the equivalence point's going to be. If you took 12.5 milliliters, that's the half titration point. pH equals pKb. The pKa of this would be 4.74. Sorry, POH equals pKb. Okay, so you're looking at 9.26 would be that point right there. Okay, now I want you to do this. I want you to pick an indicator for me for this, and I'll tell you what, it ain't phenolphthalein. Take your other hand out, flip it over, pick out an appropriate indicator. And well, I'll go ahead. This isn't supposed to be a sort of mystery. Methyl orange, methyl red, probably more methyl red. Changes right at about 5.2. That would be an appropriate indicator. One more to go, guys. Okay, how about when we have a polyprotic acid or base. Notice, that's oxalic acid. That thing's got 2 H's on it. Think about what that curve would look like. Notice how I marked my volume 25 milliliters and 50. Think about that. Reflect on that for a few seconds. Bang! This thing would have 2 waves, 2 endpoints. One where the first H plus comes off, and then you'd have HC2O4 minus, and another endpoint where the second one comes off. Which indicator you want to use? I don't know, depends on which endpoint you want to find. Guys, hang in there. This concludes Chapter 14. Chapter 15 starting next week with KSP. Bang! It'll be fun. Stay healthy.